Hi, my name is Roy Hassan. I'm a Principal Business Development Manager for Analytics and Data Lakes at AWS. Today we're going to be diving deep into AWS Lake Formation. What we're going to be talking about today is, first of all, what is a data lake? Next thing we're going to look at is what are some of the building blocks around data lakes and why it's hard to build one. And then we'll look into AWS Lake Formation and why do we need it? What is the value there? And then also, what is lake formation, right? How do we use it? And then we're going to a demo that actually walks through the console to show you how to simply create a data lake, ingest data, and set some policies so users can access that data. Before we get started, we kind of look at the many years that customers have been collecting a lot of data from their operational data stores and pushing all the data into enterprise data warehouse. Traditionally, this is how companies have been building their data-driven decision process and how customers have been driving insights and doing analysis on their data. But over the years, data has really been multiplying. We're looking at a lot of data being collected, not just from these operational data stores, but also from other systems like IoT devices, mobile devices, web analytics, etc. How do we get that data into the existing sort of model of an enterprise data warehouse and still be able to process that data quickly and get insights? But it's not just that data. There's also more people and even more applications that are starting to access that data in many different ways. Traditionally, it's been BI tools for visualization and for reporting, but now we have Jupyter Notebooks for data science. We have big data tools like Apache Spark and Presto that users use to be able to analyze the data in different ways. We're still going to be able to have a platform that scales and also give us the option to bring whatever tool we want to be able to analyze that data in a nice and easy way. So what is a data lake? A data lake is really a centralized but yet secure repository that allows us to, first of all, govern the data, right? All data we collect, we have to be able to govern it, but also discover and share so we can expose that information to the rest of the organization so it's easy for them to find what they're looking for so then they can analyze that data. But the data can be structured or unstructured and also at any scale, right? We don't want to limit our ability to access that data because of the capacity that we have today in infrastructure. We want to be able to expose that regardless of how much data we have. So let's look at what are the kind of the building blocks of building a data lake and why it's a bit more difficult today. So building a data lake today is a bit more of a manual process, and it is slightly more difficult than what you normally want. So typical steps that it takes to build a data lake. First one is around ingestion and cleaning. So we have to set up some storage. When we store the data on our data lake, we have to define a pattern that makes sense for us to store the data and also discover it later on. We then need to find ways to move the data from your operational data stores into your data lake. Once the data has been staged into your data lake, we want to be able to cleanse it, prep it, and really get it ready for consumption. And once it's been processed, we got to be able to catalog it so it's exposed to the rest of the organization. But before giving users access to query that data, we have to make sure that we enforce security, right? We have to define what policies are allowed on each data set, who can access what, and what portions of the data can they get access to. So once we've done that and we created that policy model, then we expose the data to the end users to be able to go query that in a number of different ways, right? Whether it's a data warehouse or a SQL engine or data on S3 or some data science tools, they want to be able to use their tools, but in a secured and governed way. So there's a lot of different steps here that we have to go through to be able to make sure that the data has been processed, it's ready to go, but it's also secure and accessible to our users. Those are the different users. We'll talk about those guys later on. So today, when we do this, there's a lot of different steps to go through that. We have to discover what sources exist, right? Do we have data in S3 already? Do we have data in some operational databases like MySQL or Postgres? We have to then create a storage location in S3 where we want all of our data to be stored. We have to configure access. So we have to go to S3. We have to configure bucket policies that defines which services and which users can access that physical data in S3. Now we have to go and we have to crawl them. We have to map those tables in S3 to actual tables in a data catalog. Then we have to go and write some ETL jobs, right? Some data transformation jobs that consume the data from the source, transforms it, cleans it, preps it, and then loads it back into a refined zone in S3 that's easy for our users to query. Then once again, we have to create metadata policies, and we'll talk about that a little bit later on. But in the Glue data catalog, we have to define which user has access to which sets of resources, right? Tables, databases, etc., to be able to actually create that data. We also got to go in and configure some policies in our applications themselves, right? Whether it's inside of Presto, inside of Hive, inside of Spark, so they can actually access that data in an efficient way. And then we do the same thing over and over again. As we add new services and new data stores to our data lake, we have to keep doing it. As new users come in, we have to keep maintaining this environment. This is really kind of manual process. It's error prone. It just takes a lot of time. So how can lake formation help us here? So lake formation really takes that whole effort, right, and just simplifies it. It goes from months of creation to multiple days to be able to get this done. The first thing is we start with S3. S3 is a cost-effective, super durable storage, and it gives us global replication capabilities. So if we need to move data for high availability or redundancy purposes, we can move it to different regions very, very simply and cost-effectively. The next thing is lake formation comes in and sort of layers this capability on top of that, allows us to simplify the ingest and the cleansing and the cleaning of all of our data. So this is where our data engineers come in and sort of build these processes for us to help move the data in and prepare it. Then once that's done, the security operators or security officers in your organization can come in and help us kind of define the right security policies on top of our data, right? This is data that's been stored in S3, data that have been ingested and cleaned and ready to go. Now we're layering some security policies, and each one of these security officers may belong to different lines of business or to different groups, right? So they have autonomy around who manages which bits of data for their group and for their organization. And then ultimately be able to bring in analytic tools, machine learning tools, big data tools, to be able to integrate into this platform to give every user the ability to access that data in whichever way makes sense for them. Okay, so what exactly is lake formation? So lake formation, think of it as a set of tools or capabilities that enables these data engineers, security officers, and even data analysts to be able to build, manage, and actually use the data lake. And let's go see what that actually means. So the first one that we have is more on the ingestion and cleaning. This is where sort of the data engineering organization comes in and helps us. And we're using AWS Glue, this serverless capabilities. We'll talk about blueprints and ML transforms that kind of fit into this mold. Before I go there, let's just quickly talk about what AWS Glue is. So AWS Glue, there's three different components there. The first one is a data catalog. Think of it as a technical metadata repository that stores schemas, column types, column names, etc. We also have a capability to automatically crawl and discover data in your different data sources and then expose that into the data catalog. So you have a single place that can manages all the metadata for your data in your data lake. The second component is a serverless data processing engine. There's an Apache Spark environment and also a pure Python environment that allows you to sort of take the data and process it in different ways, and you have these multiple capabilities. And then the last piece is orchestration. Be able to take the discovery, the crawling of the data, take the Apache Spark and the Python serverless engines and put them together into a workflow that can create the ingestion, processing, and population of the data catalog for different data sources. So put all these things together, we have a nice way in a serverless environment to be able to ingest our data and process it. Lake formation integrates very, very well with AWS Glue. And this is just a high-level diagram of what that looks like. So you see on the bottom in the orange, we have the AWS Glue ecosystem. The bottom layer, we have the Glue ETL jobs. These are the Spark and the Python shell, the Glue crawlers, the discovery mechanisms of data sets. Connections, this is just a way for us to manage how we connect to databases outside of the Glue ecosystem. And then we have the Glue data catalog that maintains the metadata of all these tables that we discovered, and the workflow engine that puts it all together for us. Now, lake formation is a set of tools that rides on top of that. And the blueprints are basically a way for us to automate the creation of workflows, the creation of Glue ETL jobs for common use cases. Then the security aspects and the search and collaboration is a layer on top of the Glue data catalog that makes it much more business friendly and user friendly to be able to discover and define policies on the data that you discover to be able to give access to other users. And then monitoring throughout the entire process, we have auditing and monitoring for all these different systems to be able to see who accesses what, who sets configuration, who changed the permissions on tables, etc. So you always know what's going on. So when we talk about blueprints are, think of them as predefined templates, right? They serve common ingestion use cases, such as bringing data from an on-prem database onto your data lake, taking AWS service logs and converting them, transforming them, and making them available in your data lakes for operations and security folks to be able to query those. They automatically build AWS Glue workflows for you. So you can actually go and build those on your own. But for these common use cases, we already went through the effort of building those for you, creating all the Glue jobs, the crawlers, and all the different pieces that needs to move the data from point A to point B, build all the best practices into them, and make it available to you as in a template. We will also automatically populate the data catalog for you. So once the transformation completed, it's there ready to go for you to be able to consume it. Here's just an example of what a Glue workflow looks like. And this is a Glue workflow that was generated by a lake formation blueprint template. And we'll see in a demo in a little bit of what this looks like again. So again, just to kind of come back to this, with blueprints, you tell us what is the source data set or data store that you want to read data from. Tell us what is the destination, where on our lake do we want to store this in S3. And then we specify a frequency. How frequently do we want to run it? Once a day, once a week, once an hour? And then we can then automate that. And behind the scenes, the blueprints basically discover the schemas of that source, read the data from the source system, converts it to an optimal file format on S3, partitions it automatically for you based on some best practices, stores the data in S3, and then also tracks the entire progress from start to finish to give you a status of how things are going if anything fails throughout. And then because all of these steps are actually built inside of AWS Glue by the blueprint template, you actually have full control over that system and be able to go and customize it if you feel that that was necessary. So you can always go to the job itself and tune it and tweak it to meet your needs better. So it's a great starting point, and then you can go and tune it from there. Additionally, when we talk about lake formation blueprints, another component is what we call machine learning transformations. And this is a component that basically takes a look at some of the common data transformations that our users have been doing that have been a bit more complex and required a bit more sort of manual intervention to be able to get it right. And one of those things is find matches. So find matches is a machine learning algorithms that we put together that trains on a little bit of your data, and then you can incorporate into your workflow to be able to do two main things. The first one is to identify and deduplicate rows. So find rows that are very similar and deduplicate them, but also use it for to be able to match records, right? Because when we run through this, we give score to each one of the rows to say how similar it is to other rows. Based on that, we can use the logic of deduplication and say this row is very similar to these other rows, so I'm going to remove them. Or we can say that I'm looking for a specific shoe. I can actually use the scoring that was introduced into the data set now to be able to say, based on the shoe that I selected, show me all the similar shoes in my data set that match this criteria, right? So now we can deduplicate, but you can also do record matching. Okay. Moving on to the security officer sort of role in this environment. So their responsibility sort of lies within the data catalog. They're the ones responsible for defining the permissioning layer, but also monitoring and auditing of the entire system. So when we talk about data catalog and permissioning, there's really two sort of ways to look at it, right? We have the lake formation that we're just talking about right now. But before lake formation, we had AWS Glue using the data catalog. Now, they both share the same exact data catalog, but from a permissioning perspective, there's two different permissioning models. You can choose between the Glue permissioning model that uses IAM policies defined on Glue resources, such as catalog, database, and table, or you can use the Lake Formation permissioning model that uses a simplified sort of grant and revoke model to define policies on databases, tables, and even columns at a much more fine-grained control. Now, the Lake Formation model gives you further capabilities in the sense that it does token vetting, and we'll talk about in a minute what that means. Now, for backwards compatibility, by default, when you launch Lake Formation, we allow the Glue permissioning system to work, right? Because many of our customers are coming from Glue-based permissioning model and data catalog, so we don't want to disable that, right? So automatically we allow that, we enforce that as the default sort of system. So as a user, you have the option to switch to the Lake Formation model by disabling the Glue permissioning model. Okay, looking at what Lake Formation permissioning model looks like, the first thing is you do is, as an administrator of the data lake, you define user permission on Lake Formation resources, and those are databases, tables, columns, and then we define who can access what. Now, the next thing, once that's been defined, the user comes in and say, hey, I want to be able to get access to a particular table using Amazon Athena to be able to analyze that data set. When a request comes in for Athena into the Lake Formation service, Lake Formation then has to authorize that user based on the policies that the security officer defined for them. Now, with the concept of token vending, what happens here is that the policy is defined in the Lake Formation layer. Now, Lake Formation also gives you the option of defining a bucket as being managed by Lake Formation. And what that means is that Lake Formation will retrieve temporary credentials on behalf of the user to be able to give the service, Athena in this case, ability to scan the data without actually giving the end user access to the underlying S3 buckets. So no longer do you have to configure your policies at the metadata and the storage layers. Now you define them in one place, right, in Lake Formation, and Lake Formation manages all the S3 policies for you. Now, with Lake Formation, we can take it even further. Instead of just defining policies or permissioning based on databases and tables, we actually have control down to the column level to be able to give users different views of the data based on what they're allowed to see, right? And then also, once that's done, you can actually audit who has access to which parts of the data set, and also who is given permissions to those users, right? If a user is giving somebody else permission to a data set that maybe they shouldn't have, you should be able to have ability to audit that and be able to go back and resolve that problem. Now, going back to what I said before around upgrading. So you saw up till now that there's a model of Glue access and policy definition. There's also the Lake Formation one. So when you first bring up the console of Lake Formation, you'll see a message that says, hey, data is being given out to a lot of different users. We want to be able to contain that. So by default, if you don't do anything and you don't want to use Lake Formation, you leave it as is. And all of your Lake Formation all of your Glue IAM-based policies remain the same, and all the data is locked down based on what you previously defined. If you do want to move towards the Lake Formation model, this is where you start through a upgrade process that we have defined in our documentation. And it's actually a very simple process. The first thing is you try to understand what are the existing policies. So you go and you look at your IAM and you see which users have access to which data catalog resources. Also, which users have access to which S3 buckets, right? Once you've defined that, you can go into Lake Formation, you can model those same policies in the Lake Formation language. So you look at the IAM policies that say user Roy has access to table users. I'm going to go into Lake Formation. I say user Roy, grant him permission to table users in Lake Formation. So now we took the permission from Glue in IAM and we modeled them again in the Lake Formation model. Now, once we've done that, we go into the Glue environment, we remove those permissions from Glue, and we then we turn Lake Formation permissioning model on, and we let Lake Formation manage it. So it's a process, but throughout this entire thing, the data is still locked in only to your account, only to the IAM principals that are allowed to access your data catalog. At no time do we expose that data to anybody else. So that's always a controlled and a secure process of you moving from one model to the other. And this is all further documented in our documentations online. Okay, now moving on past security, when we look at lake formation, we talked about before how lake formation introduces another layer of a data catalog. And this is not really another catalog. It's really a business view, a more user-friendly view on top of the data catalog that we previously had with Glue, where now you have text-based searching, ability to kind of look at all the metadata across your entire system, entire data lake, to be able to discover which data sets exist. So you don't have to look for individual tags. You can just put in a free-form text in there, and we'll scan through the entire metadata catalog to find relevant tables or data sets that you're interested in. You can also add attributes such as like tags into your tables and your columns to be able to annotate them with more business context. So it's helpful to the end users that are discovering these data sets to understand how these tables are related and who's responsible for them and what are some of the business context around them. So that's, again, very helpful, give you more business sort of view into the catalog. So when you're discovering this data, you have more business context rather than just the technical metadata aspects of it. And then also with regards to auditing, right, this has to be a way for us to audit everything. Now, all the APIs, all the calls, all the transformations, all the changes that you're doing, everything gets captured in CloudTrail and can always be audited later through the CloudTrail system, or actually using Amazon Athena to be able to analyze the CloudTrail data. But you can also, in the Lake Formation console, get a real-time view of activity as users querying the data sets, which users are coming in, what permissions do they have, who is modifying permissions. So you get the real-time view of auditing and monitoring inside of your Lake Formation console. Lastly, we want to talk about the analytics and the data science user. So for them, once we've built this data lake, we've ingested the data using our blueprints, we store the data in S3, we cataloged it in our Lake Formation catalog, we put policies around it and security and controls around it. Now we want to expose the data to our end users to be able to actually analyze it. So using the compatible services such as Amazon Redshift, Amazon EMR, Amazon Athena, and also AWS Glue, they are currently directly integrated with the Lake Formation policy model to be able to give you the ability to access data in a controlled and governed way. So using those systems, you can define policies on tables and columns level and be able to give your users access. Okay, now let's look at a quick demo. Oops. All right, so this is the Lake Formation console. When you open up the console, the first thing you're going to see is this is the dashboard. So dashboard kind of calls out and say, hey, there's 3 different stages to get started. We'll talk through that, but you can very quickly see here sort of recent activities. You can see that Roy has been revoking some permissions. He's listing permissions. He's also doing some other work. There's also this user analyst that's been doing get data access, which is basically they're making a call into a table from some service. And we can look at that later on. Now, before we do anything, the first thing we want to do is we want to go into the admins and database creators. Now, before you can do any of this that I show you here, you have to create an IAM user that has administrator privileges to be able to call the Lake Formation APIs as you would in any other service on AWS. Once we have that user created, we actually want to go and we create a data lake administrator. In my case, this is Roy. He's the data lake administrator. He has some additional permissions around being able to grant policies to users or to get access to tables to users, but he's responsible for our entire data lake. Now, I also want to give Roy the ability to create databases, right? It's not enough that he can just hang around and monitor stuff, but he needs to be able to create databases so other users can do stuff as well. So Roy is an IAM user and he creates databases. And we can easily grant other users, let's say in this case, maybe Dan, and we wanted to say that Dan has ability to create new databases in this catalog. Now that we have these two users, now only Roy is administrator, but Dan and Roy have ability to create databases. Now, the next thing we want to do is we want to go back into the register and ingest data lake locations. So this is where we define, or at least we register a specific S3 bucket as our data lake location. Now, by default, lake formation does not take over your S3 buckets. You have to explicitly designate which buckets or which prefixes in S3 are to be part of your data lake. So in my case, it's Roy and demo /ALF, and then we assign an IAM role to it. Now, if you don't have a role, we can create one for you, but I already had one here, so you can see here, I can just create another bucket, and then I can pick a different role. I already have some. We have in the documentation a way for you to kind of look at what policies are required, but very straightforward. We create this role. Now, this role is going to be used by lake formation to be able to request permissions or get temporary credentials to this bucket to be able to read and write from it. So now, once we have these permissions here, the next thing we want to do is you want to be able to go to our blueprints, and we want to create a blueprint job. In this case, I already created one for my CloudTrail, but it's actually a very simple process. You go in here, you can pick a database snapshot. In my case, it's CloudTrail. You know, I have some CloudTrails already created. When do we want to start this? I don't know if we want to start today. I started tomorrow. And then we pick a target. Where do we want to store it? My lake formation, see, already populated the bucket. It's going to save it in Parquet format. The frequency that we want to run, let's do this daily. And then we got to give it some workflow parameters. Now I'm going to cancel out this because I created one, so we don't have to go through it again. But you can see here when I open it, I have my blueprint. This is the workflow ID. So let's just click on this one and see what that looks like. Okay. So as you can see here, I already ran this once. It completed everything. If we go look here, what you can see here is you can see the entire workflow that was created by the blueprint. So it might be a little harder to see here, but you know, we have the blueprint. There's some parameters. We have a crawler that's running. We have some ETL jobs that are running, and then everything completed. We can see the check mark on top of it. As this is running, you can actually go into the screen and see it real time as things are updating. So now we know that our blueprint executed and it created a job. Now we can go into our tables and we can see which tables was created. Now in my case, I just care about this particular database. So let's go look here. We have one table, some sentiment table that I created previously, and this is the one that our a blueprint created. So you can see here, I ran a bunch, was able to find some data. There's a whole bunch of partitions that were created here. You can see based on region, year, month, day, and there's files pointing to S3. So in this case, at this point, we have a table. We don't really have to do much beyond that. Now, the next thing we want to do is we want to go into data permissions. Now, let me just clear my filters. I have a bunch of different information here. So when I look at data permissions, we can see sort of who are the principals that have access to what sort of resources. There's a bunch in here, so let's just go and create another one. So I want to go in here and want to say, hey, analyst, I want to give you access. And I want to give you access to lake formation, to my ALF database that I created. Now I can pick tables in my database if I wanted to. In this case, I'm going to do CloudTrail. And then I'm going to say, okay, I'm going to can either give you access to everything, right, all the table. But in this case, I know there's some sensitive data in there. So let me just specifically include individual columns. In this case, I want to give it the event version. I want to give the source, let's see, name, and also the time, because some of the other things are a bit more sensitive. So I'm going to give the user only select permissions because there's no need for them to insert or alter or change my table at all. And then I'm going to click grant. In this case, we can see the user Roy has permission to the CloudTrail table. He can do anything. User analyst also has permission, but only to specific columns. And these are the columns that we defined. And they only get select permissions to those columns. Now, once we define those permissions, the next thing we have to do under the permissions is actually define locations. Now, this basically enforces the credential vending that I spoke about before. So we talked about data lake location. So we registered this bucket with this role as part of the lake formation service. And here is when we actually enforce the credential vending and say that whenever a resource tries to access this bucket, we're going to use this principal, this role, to be able to get temporary credentials for that. Right, so now that we have that, let's just switch into my user here. Just refresh that. So you can see this user is actually analyst. And you previously didn't see this table, but now you see both of them because user has permission to do both of these tables. Now, if you click here, you can see here that we only have the columns that we were given permission to. Now, the one thing you see here is that you have access to all the partitioning columns. Currently, we don't restrict access to the partition columns because they're part of the query and they're required. So currently, you cannot restrict access to them, so they automatically are given. So now that we have this, we can actually go and we can say preview. And we can get all of our data. And you can see here, granted we did a select star, we actually only got the columns that were relevant to us. And you can see you got the version, the time, the source, the event, and none of the sensitive columns that could have included maybe account IDs or something like that. Right? So that's it. And if we go back to our console here, we can actually look at the dashboard and we should be able to see the analysts making queries, right? So if I click on this and I go view event, now I can actually go in here and I can say this IEM user, you can see here, did a select query and some other information. So this is all relevant information when you try to troubleshoot or at least try to audit where things are going. So that's it for a very quick demo of the AWS Lake Formation Service. Definitely go to the website and read more documentation. Let me kind of go back to here, and then last piece of it is Lake Formation, really no additional charges. You only pay for the underlying services they use. As you saw previously, Lake Formation rides on top of the AWS Glue. So if you run a blueprint, it executes Glue capabilities such as the crawlers and ETL jobs. You pay for those services, but you don't pay for the blueprint templates that we create for you, right? The same thing for the data catalog, right? You use the Glue data catalog, you pay for the resources that uses, tables, partitions, etc., but you don't pay for the policies, for the permissioning, for the token vending that comes in with Lake Formation. And that is it. Thank you very much. If you have any questions, you want to learn more, please go to our website. If you do have any questions, you can shoot us an email at lakeformation-feedback@amazon.com. Okay. Thank you very much.